Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0103, indicates an issue specifically related to the mass airflow MAF sensor circuit characteristic in Honda Civic models from 2016 to 2021. When this code is triggered, it signifies that the MAF sensor is reporting a high voltage signal, which suggests potential problems within the sensor or the circuit itself. The MAF sensor is a critical component located in the intake air duct, just before the throttle body. It measures the amount of air entering the engine, allowing the engine control module, ECM, to adjust the air-fuel mixture for optimal combustion. If the signal exceeds a specific voltage threshold, clean operation of the engine can be compromised, leading to various performance issues. Understanding how to diagnose this code is essential, as it not only helps in rectifying the MAF sensor error, but also impacts the overall engine performance. The DTC P0103 points to a critical malfunction within the MAF sensor circuit. The MAF sensor plays a vital role in measuring the volume and density of air drawn into the engine, providing data essential for the ECM's fuel adjustment calculations. This code indicates that the MAF sensor is sending a voltage signal that exceeds 4.89 volts, thus flagging it as an operational issue. Located in the intake system, this sensor is usually positioned upstream of the throttle body, which means any faults could significantly affect the quality of air entering the combustion chamber. If the MAF sensor circuit indicates high voltage, it may lead to rich fuel mixture conditions, which can adversely affect emissions and fuel economy. It's essential to ensure that the sensor is functioning correctly and that the circuit is intact to avoid further complications. Understanding the potential causes of DTC P0103 is essential for effective troubleshooting. A faulty MAF sensor is often a primary reason for the high voltage signal, which can result from internal failures or contamination. Open wiring between the MAF sensor and the powertrain control module, PCM, can also lead to this error. Poor connections, loose terminals, or damaged wires in the circuit can create intermittent or faulty signals. Additionally, a defective PCM can cause incorrect readings from the MAF sensor, which may need to be validated through further diagnostics. Overall, a systematic check of these components is necessary to pinpoint the exact source of the issue before any replacements are made. When DTC P0103 is present, various symptoms could manifest, impacting the vehicle's overall performance. One of the most common indicators is the check engine light illuminating in the dashboard, prompting a need for diagnostic checks. The engine may exhibit performance issues, such as stalling, rough idling, or hesitation during acceleration due to the incorrect air-fuel mixture caused by the faulty MAF readings. Additionally, drivers may notice a decline in fuel economy as the engine struggles to maintain optimal efficiency with inaccurate airflow measurements. Overall, these symptoms underscore the importance of promptly investigating and addressing the underlying issues associated with DTC P0103 to maintain vehicle performance and reliability. The first step in troubleshooting DTC P0103 involves verifying the existence of the problem through a systematic approach using the Honda Diagnostic System HDS. Begin by turning the vehicle's ignition to the on position and allowing the system to stabilize for at least 2 seconds. This action prepares the vehicle's onboard diagnostics, enabling accurate readings. Once the system is ready, check the MAF sensor's voltage signal with the HDS tool. The key reading to observe is whether the signal exceeds 4.89 volts. If it does match the threshold, the issue is confirmed, and you can proceed to the next troubleshooting step. However, if the readings do not match, intermittent faults may be present, such as poor connections or intermittent failures. which also need thorough checks at the MAF and PCM connectors. The second step of the troubleshooting process requires checking for open wiring issues in the vehicle ground monitoring (VGM) line. Begin by switching the vehicle to the off mode. Then, utilize the HDS to jump the SCS line for an effective diagnosis. After waiting for 1 minute, disconnect the connectors from the MAF sensor and the PCM, specifically the E80P connector. This step is crucial to isolate the components and ensure accurate testing. Subsequently, check for continuity between the designated test points, which are the female terminals of the MAF sensor's 5P connector and specific pins in the PCM connector. If continuity is confirmed, it indicates that the wiring is intact. If not, investigate and repair any open circuits between the PCM and the MAF sensor to ensure signal integrity. In this final troubleshooting step, focus on verifying the internal circuit functionality of the PCM. Begin by safely reconnecting the PCM E80P connector to restore the electrical path. Then, like before, check for continuity, but this time between the same MAF sensor connector pin and a suitable body ground. This verification confirms whether the internal circuit of the PCM is intact. If continuity is observed, it's an indication that the PCM is properly processing signals, and the MAF sensor should be replaced as it likely failed. Conversely, if no continuity is found, there may be additional issues at play. In such a scenario, consult authorized service manuals and consider substituting a known good PCM and re-evaluating the situation to determine if the original PCM needs replacement. After completing all necessary repairs recommended for DTC P0103, conducting a final verification is critical to ensure that the issue has been resolved effectively. Begin by performing a test drive of the vehicle in various driving conditions to stress the engine and the newly installed components. Monitor all dashboard indicators, especially the check engine light, to confirm that it remains off during and after the drive. Additionally, pay close attention to engine performance. It should operate smoothly without signs of stalling or hesitation. If no new DTCs arise and engine performance meets expected standards, then the repair can be considered successful. If DTC is triggered again, revisit previous steps to ensure no underlying issues are left unaddressed, ensuring the vehicle's reliability and performance. Preventive maintenance plays a crucial role in mitigating future occurrences of DTC P0103 related issues. Regular cleaning of the MAF sensor using appropriate sensor-safe cleaners can help maintain optimal functionality and prevent buildup of contaminants that might interfere with accurate readings. Additionally, frequently inspecting electrical connections for corrosion or looseness can help ensure that robust signals are transmitted to the PCM, minimizing reliability issues. Lastly, adequate airflow through the engine is essential. Hence, maintaining a clean and efficient air filter should be a standard part of vehicle maintenance. Establishing these practices can lead to improved engine performance, enhanced fuel economy, and prolonged sensor life, ultimately preventing costly repairs in the long run. In summary, understanding DTC P0103 and its implications is vital for any Honda Civic owner from 2016 to 2021. The MAF sensor plays a crucial role in the engine management system, and issues flagging this DTC can adversely affect vehicle performance and emissions. A structured and systematic troubleshooting approach allows technicians to accurately identify the issues surrounding the MAF sensor circuit. Through verification of signals and thorough checks of wiring and connectors, precise solutions can be implemented to resolve the fault. Moreover, Taking preventive actions, like regular maintenance, will not only ensure the reliable operation of the vehicle, but will also save on repair costs in the long run. By being proactive and informed, vehicle owners can enjoy better performance and longevity from their Honda Civics. Please like and subscribe to the channel. See you next time!